Welcome to today's webinar, Truly Constructible Information, How Concrete Contractors are Demanding More from BIM. My name is Cheryl and I will be your operator for today's call. At this time, all participants are in a listen-only mode. Later, we will conduct a question and answer session. During the question and answer session, if you have a question, please press star, then 1 on your touch-tone phone. Please note that this conference call is being recorded. Our speaker for today's conference is Sam Cummings. Sam is the Global Product Manager of Tekla Structures for Trimble. He comes to Trimble with a degree in Construction and Project Management from the University of Huddersfield. As the Rebar Product Manager, Sam utilizes his years of experience in designing and detailing concrete structures to influence and strategically plan the future of Tekla Structures for the concrete market. I will now turn the call over to Sam Cummings to tell you a bit more about what he's learning from concrete contractors and why they are demanding more from their BIM tools. Sam, you may begin.
Afternoon, everyone. First of all, I'd just like to check if everyone's audio is okay, because there does seem to be a little bit of an echo. Okay, so what we'll do is we'll begin. So first of all, thanks for the introduction. Some of you may know me. I've worked for Trimble for 5 years in both the UK and the US, concentrating on concrete contractors and reinforcement detailing, and generally how we can forward BIM products and actually help contractors work. I've probably worked with a couple of you before. I noticed a couple of the names on there as well. So a little bit about today and what we're trying to achieve. I'm going to try and explain exactly what BIM is. It's an information management process, and by the end of this webinar, you'll actually understand exactly sort of how we can use it to better work out our contractors and work out with concrete. Also, I'm going to explain to you guys exactly why you should be using BIM, and we've got a number of different things on here that you'll be able to say. Please ask questions. I can see the questions. I'll ask them towards the end. So first of all, what exactly is the problem that we're actually looking for, or what we have at the moment in the construction industry? And it's when we use drawings, traditional quantity takeoffs, schedules and reports, when we're trying to use those to communicate to the various different project stakeholders. As the project progresses, information is actually lost as we pass the information from one person to the other. For example, when I study a set of drawings, it doesn't enhance your understanding of the project, and it only enhances mine. But with a model built in 3D software, our shared understanding of the project continuously builds over time. Any enhancements to the model that we make enhance our collective understanding, because we can see and access all of the information quickly and easily. The model becomes a place where we're actually able to store all of the information at every single stage. You can obviously see much more detail in 3D than you can in 2D. And a project manager, for example, can stare at a 2D drawing sheet for weeks and not have a thorough understanding of the project. And it's possible after sort of 15 minutes of looking on here. Now, BIM is something that's used. We often hear the words level of development or level of detail. And two of those things are slightly different. And here we have two documents that sort of help to clarify those. A little bit of background for everyone. In the 2000s, the American Institute of Architects actually realized that with more architects using 3D models to complement drawing information, be it BIM or models and drawings, that delivery of information at key phases of the project needed to be quantified and qualified. And their think tank actually brought to light a schema called level of development. Not quite the same as the acronym level of detail, but very similar. As I said, these are the two ones on here. We've got the AIA document and also the BIM forum specification. if everyone wants to go and have a look at that later on, then there's obviously the web page for it just there. But what does this actually mean? What do these documents show, or if we were to read them, what would we summarize? And that's what I'm going to try and do for you at the moment. So definition of level of development. The level of development is the degree to which an element's geometry and attached information has been thought through. The degree to which the project team members may rely on the information when using the model. So let's take, for example, two well-known softwares. We have SketchUp, which could be classed as LOD 200 or level of development 200. And the reason why is because you can see the elements that are actually there, but there's no great detail, there's no welds, there's no bolts or anything like that. And then you have a look at sort of constructible models, as we can see in the image below, where you have the bolts, the welds, the stiffener plates, real constructible information that we have inside there. And let's have a look at some examples of different types of LOD for different types of construction. So here, for example, if we have a look at a facade building, okay, we're going to be able to see that the geometry at LOD 100 is just an area. It's just an approximation. And as we actually move forward through these levels of development, we start to introduce thicknesses, dimensions, profiles, weights, in this particular case U values, areas, surfaces, that type of thing. Another way to look at it is when we have a look at MEP, or any sort of electrical type, or any duct or pipe work. And again, it's the same type of thing. We have lines and developing all the way through these different levels of development, all the way up to, you know, LOD 350, for example, where we're specifying specific manufacturers and we're detailing every single thing that's required to fit that. And something that's a lot more familiar to all of us is obviously a frame that we have inside here. And you can see we're going from, obviously, the stick model there to geometry with profiles and reinforcement, etc., bolts, that type of thing. And one thing to really sort of summarize from those documents is not just the different types of level of development, and I'll keep saying that throughout today, but actually what we can use, or the authorized use of these different levels of development, for example. So we have this model element table, and we're able to see here exactly what we can use. So people are filling in the level of development for this project milestone, for example. And as we go forward through the separate project milestones, the type of level that are required at that point. And what do I mean by authorized use? So if we have a look at this extract from the AIA document, it gives us the definition of these authorized uses. So the model element may be analyzed for performance of selected systems by application of specific performance criteria assigned to the representative model element. So basically what we're saying is that this model geometry is that good, the information is in there that we can use it to schedule and coordinate and cost, because everything is completely correct inside the model. But how does all of this information and these different levels of LOD actually benefit us when we're modelling, or benefit a contractor of any type? And go back to here, just the simple LOD as we've seen previously. And these are LOD 300 targets up to this arrow here. And then we have these LOD 400 plus BIM targets. What actually fills in the difference? What really fills in the middle between these LOD 300 and these LOD 400? And that's RFIs. These gaps are filled by questions that are coming back from site or stakeholders that are in the project. They're coming back with change orders, so it's actually costing us money, and they're coming back with causes for delay inside there as well. A little bit prettier representation of what we just went through here, and again we can see the communication gap inside here. Actually, as we move up these levels of development, it gets a lot smaller until we get to the LOD 400 level, where everybody is involved as early as possible, which means that we have a lot less requirement for questions, change orders, and obviously mitigating risk inside there as well. Essentially, more people have got more information to make much better decisions. There's actually a study by OpenBIM that I thought I would share with you guys today. And this basically compares projects that have used IFCs. So for those of you that aren't too sure what an IFC is, it's Industry Foundation Class. It's essentially a read-only 3D model that's intelligent with data on there, so weights, volumes, user-defined attributes and things. And what this shows is where an IFC is actually being delivered as a piece of documentation, the low quality 2D information is automatically reduced, simply because the effort has gone into the 3D model, and you can see a lot more from this 3D model inside here. And of course, if you don't demand this sort of LOD 300 minimal going forward, you won't actually get the benefits of it. So one thing I do want you guys to think about as we go through the rest of the webinar is, how is your team working? Are they working in a high or a low risk environment? And just to sort of clarify that for you, high risk on the left, low risk on the right, and you can imagine what I'm going to say next. The left-hand side is got low level of development for the MEP and the concrete geometry and the steel work. We've obviously got clashes inside there, but this can really start to be mitigated by going up, and the more information we put into the model, obviously the less clashes we get inside there, and the better the project's going to turn out in the end. Here is a project done by Arup. Some of you may have seen it. If anyone's sort of fairly active on LinkedIn or whatever, you'll see these kicking around. And essentially, the option A, which is the blue at the top, shows a traditional method of procuring and actually working through the project. And option B shows us when we're actually using intuitive 3D models and we are all collaborating at the same time. And you can see that time saving inside there. And it reverts back to the second slide that I showed you, that if we all collaborate together in the same type of model, then we can get things done a lot quicker. It's a little bit more effort at the start, but it does lead to huge savings going forward. And those type of savings can be quantified by these type of projects. So I think everyone will know exactly what this is. It's hoods and the yards. It's 72,000 tons of steel. And it's got with a traditional delivery schedule. This 6 months time saving wouldn't actually have been possible because of the time scale of the procurement. But doing this a lot earlier in the project means that we're able to move forward like that as well. And obviously cloud-based solutions, model sharing solutions, those type of things, and internet-based working allows people to work 24/7. Again, going up to this level of detail, 350 on this entire on the Port Canal project. There was only 10 RFIs, as we can see there, which means that all the information, all the questions have already been asked in the model stage inside there. And then finally, a little bit more this sort of steel project. You can see here that the first tender, from the information, there was actually no clear winner. There was a load of different bids. The bids varied very, very dramatically. On the second tender, it was required that, you know, a little bit more thought, some modelling, up to a better level of development came into it, and the bids actually came in with only a 10% spread. So it goes to show for itself that there's certainly worth in working in a BIM environment. So moving on to how you guys can actually leverage the use of a constructible model. Well, the key word is actually constructible. If we take in the information created at the quantity takeoff stage, when we've modelled everything, so we have the embeds, we have the formwork, we've got the reinforcement inside there, and adding even more information to it, such as the poor planning, the actual scheduling itself, and using site set out, we're able to leverage that inside there. And we're going to go into detail now, kind of put aside the level of development, and hopefully we've got that one home, and let's see how we can actually benefit from models in real life environments, and how we're using it. So if we have a look at how we take our first steps in pre-construction planning, planning, design, and estimating inside here, what we're able to see here is that there's absolutely no reason why you can't use tight sort of traditional ways of working. So we're able to add 2D information, whether it be PDF, DXF, DWG. All of the BIM softwares now actually allow you to add these things in. So we're sort of taking it up a step from the digitizers and actually tracing over PDFs to doing exactly the same type of thing, but just in 3D and having a 3D model towards the end of it. Using 3D modeling software, it doesn't mean that you can't work in that sort of traditional way. And elements are really, really easily moved around going forward inside there, as you can see. This is just a very interesting model here that you can get very, very quickly when you're using 3D software. It's possible to visualize that project just as you build it. As many of you will know, it does take years of experience to actually take 2D information and visualize the details that are required inside your head to actually, take this off and find the information that you need. BIM allows you to actually find design issues before they become a problem, or if it's not a design issue, you actually have the time to plan and put the extra effort in to make sure that there's no problems when you get out onto site. It also means that at any point you can really start seeking the information from here and inquiring these and finding out the geometric information, again, profiles, weights, that type of thing. Referring back to our sort of LOD structure or level of development, the more information that you add into the model, obviously the more accurate and ultimately efficient the construction is going to be. As the old saying goes, you measure twice, you cut once. Well, in actual fact, what we're doing here is the 2D information is the information that we're receiving. The second time we're doing it is building a constructible model and putting this information in, and then we're actually just building this once without any problems and without any issues. Adding rebar to models hasn't actually been any ever easier, especially when you have the concrete geometry there in front of you to actually follow, if you like. And the beauty of detailing in 3D means that this is actually a one-to-one scale. The model is life-size. So the bars that we're modeling in show real-life constraints. And it means you can start to consider things that you might not have thought of before, like fixing constraints and those type of things. Just to quote a colleague, Tony Woods of Midland Steel, a rebar fabricator in the UK. He said, we evolved the contractor and the engineer as such. Everybody is in agreement as to what they can physically see in 3D. And so there's no questions later on in the project saying, I never saw that in the drawing. We then plan with the contractor and the delivery sequence. The most important thing to take from this, that contractor involvement with the engineer and the client and the detailer collaboratively is the only way it's going to work. Pre-planning is obviously pre-succession, and with no planning, it's planning to really have no future. Now we actually have 3D models, it's very easy to again take that geometry and take it even further. So when working out contact area or formwork and shuttering, if you actually use a model, you don't have to trace over this 2D information anymore, or punch profiles and depths and information into Excel sheets so that it generates that for you. It's actually possible to use the model geometry. And using this geometry in the model means that where concrete crosses, you're actually able to deduct the required amount of surface area so that you can make sure your takeoffs are perfectly accurate. And many of the 3D software and 3D tools out there have automated tools in order to do this. It's just another example of modelling in 3D, where you're able to automate the 80% of mundane and time-consuming things, so that you can actually work on the parts of the model that are a lot more intricate and require more detail. Again, if we refer back to LOD and how we can make sure that we build things digitally before we break the ground, using the model means that at the forming stage of the project, so not the quantity takeoff for the contact areas, actually forming the concrete, you can not only visualize the formwork going in and how it's going to be erected and fixed in place, but you're actually able to take the full quantities right down to, example, the pins that are required. Things then like panel cycling, ordering, renting, or purchasing the formwork is made much easier. And if you couple that with the readily available libraries now of formwork that manufacturers and providers are actually giving us, the majority of this work is not just guesswork. They are actual elements that we can model in and get that constructible detail inside there. In recent years, we've seen the roles of suppliers actually change. As client and main contractors require greater visibility and more data from their sites, with the added requirements of BIM and the adoption of the digital processes. It's not actually the role of like a formwork or a shoring provider to simply just provide a product or provide a solution. It's a responsibility to interact all together at an earlier stage to make sure that we can construct these perfectly. I'm sure many people have seen videos or models, for example, like this, and know some of the things that you're actually able to do with BIM models now. So, for example, being able to have pour units inside these, which is essentially management unit for cast in place concrete. Each pour in the model, for example, is corresponding to a unit. And the type of things that you can actually add to these for the quantity takeoff is the rebar, single rebars or groups, mesh, strand, post-tensioning, assemblies like all these formwork items, for example, embeds, bolts, pieces of precast if you really wish, and then obviously surfaces that are inside there as well. And if you look, it sort of, again, it transforms things. We're only adding more information in, but it's to the benefit of the project at the time. And again, being able to take libraries of different information and actually model them in. It's a fantastic opportunity to work forward. So from here, we sort of built a model. We're actually getting the benefits of the quantity takeoff and the 3D information that are inside here. How do we sort of leverage the information for site layout, for example? And because time is money, essentially, in construction, efficiency really contributes to the profitability of a project or of the business. And field layout's an essential task where accuracy is definitely necessary. But when executed with drawings and tape measure, it can be, like a lot of the traditional workflows, really time-consuming and fairly prone to errors as well. And that's where total stations come in. They can increase the productivity of the layout process, and by integrating these actual BIM and accurate models to these layout tools, you can utilize the flexibility and the exact location information inside sort of a virtual building to make the layout tasks faster and a lot more exact. Everything you want to measure on site can be included in this constructible model. And when your structure fits in the model, you know exactly that it's going to fit on site when you go around to build these. And then you can automatically start to generate group layout points and do it a lot quicker. Same goes to once you've actually poured this information or it's been cast, you can take that information and put those straight back into the model. So stepping out from here, we sort of look at connecting this model and all this effort that we've actually put in at the bidding and then going forward into the construction phase and the planning, and what we can actually do with that information when it goes out into the field. Well, if you want things to be truly constructible, you want to share this information, and actually working better together is not just internally in your own companies. It's actually taking this information and adding it into the cloud and being able to send this down to different types of application whether it be a desktop or whether it be an Android device or an iOS device, or for example ERP or fabrication type things. You actually enable the collaboration for all the stakeholders in the project. And again, this is accessible by the desktop, mobile or web, and it allows viewers essentially to view and share and access project information from anywhere at any time if they're out on the field and they really need that. So what are the benefits really of sharing? And I kind of went over it in the previous last slide, but we have the detailer that's publishing models and sending the information out. And then we've got the fabricator that's actually able to take that information, if they want to, give design statuses and fabrication statuses and when they're shipped and that type of thing. And then we have the owner that's actually able to use these different mobile solutions, who has the major stakeholder, the major stake in this, but he's able to watch as we move forward. And then again, on site, allowing our guys on site to work safer as well as a lot quicker at that same time. And one thing that we talk about all the time is actually being able to provide this information and how we sort of get rid of all this paper that we tend to find that's out on site, so these pour cards, and adding this information inside here, and how do we get it back? A lot of the time it comes back to the project office and it's, I don't know, maybe scanned or taken all the way back to the main office for someone else to punch in. But using BIM models nowadays, we don't actually have to do that. We can use these cloud-based solutions to automatically add the different types of statusing tool, for example, that we have, and going forward with that same type of thing that we have inside here, depending on what type of platform that you're working on. It's really, really easy to actually take the information just using a cell phone and be able to send that off and work a lot closer together with that. One thing that's really come apparent and come into the foreground in the last couple of years is point cloud data, for example, and the application of that technology, which is sort of laser scanning, has been popular in the GIS environment for a number of years. And recent advances in the hardware technology and development of BIM actually helps us to give a home to these new point clouds and the data that we can get from them. And we can actually use those point clouds to optimize the building construction and the operation process as well. And while we reduce the project risk and the cost and the time to complete inside that as well. Now, scanning for the purpose of construction applies often to actual existing objects that are already on site, and those are then applied or associated to the new construction and new design that's actually there, or used for verification of placement, for example. And it's actually becoming essential more and more on some of these much bigger projects. It really does sort of play an important role in the whole integrated BIM cycle, to be able to cycle that all the way around and scan the building once it's been done and add that information back into a model. I think what I'm going to do here is just sort of finish off with a couple of slides and some sort of projects that we have that have been done. For example, so we've got Victoria Towers, which was done by Integra Engineering, who are over in Norway, and I had the pleasure of meeting them not too long back. And that's a 33-floor building, about 120 meters high. And this is all a fully detailed model with absolutely everything in there, the reinforcement, the connections that they require. And they're actually able to do things a lot quicker, just as we said, passing backwards and forwards. Here's another project. And again, we sort of go back to that safety, where we've got 0 workplace accidents with this particular project, and we're actually getting time savings of 3 months. We've got 6 months, we've got 3 months time savings inside there. The projects are starting to come in under budget, and we'll be able to utilize space inside these different buildings and these different types of constructions, so that we can sort of provide much better value to the client as well as we're going forward. Here's another one. We can see very, very similar. You see all the different types of BIM software being used, not just for steel or for car parks or for high-rise buildings, but for industrial buildings as well, which are multi-material and they have long tunnels and that type of thing. So we're really able to get right to the bottom of those. You can see there's no particular drawings on some of these projects. When we say drawings, what we say is that there are snapshots of the model that have been added and the reinforcements been added on there, and then they have been sent out because it's much easier to visualize that before we go anywhere. Moving on to a Skanska project, for example, who actually say that we should have 3D models like this in every single project, because there was actually in this project another layer of reinforcement that we couldn't have seen on the 2D drawings. You can see as things get bigger and they require much more congested reinforcement and embeds and that type of thing. We really need to work like that as well. Stepping forward to the final one over in Oslo, to another extremely big project. Customer that doesn't actually sort of check any, not necessarily just from Tekla software, but from BIM in general. If it's one-to-one, if it's right in the model, then it's going to be right on the schedules that you send out as well. And that's the end of the presentation for you guys. I think I'll take some questions now. I don't know if we have someone able to read those out.
I can give out the instructions for the audio questions at this time. If you would like to ask a question on the audio side, please press star then 1 on your touchtone phone. Once again, if you'd like to ask a question on the audio side, please press star then 1 on your touchtone phone.
No, can't see any questions.
And speakers, at this time I show no audio questions in queue.
Okay, well at that point then I thank everyone for their attention, and please feel free to get in touch if anyone wants any more information or anything like that.
Thank you, ladies and gentlemen. This now concludes today's conference call. Thank you for your participation. At this time, you may now disconnect.